Good morning, dear students. So today we have to discuss about the next part of matter. So I have already written what we have learned earlier. If you have not got it, then you see the previous video, okay, and then you will get whatever the things are written here. First thing we have learned the characteristics of particles in a matter. Okay, we have seen there are four characteristics are there. First one, the particles are very much tiny in size. Number two, the particles are having space between them. Okay. Number three, the particles are having a random motion between them. And number four, they are having a strong attraction force. These are the four characteristics, and in the previous video we have explained with the example how the characteristics is experienced here. Okay, now we are coming to the next part we have learned, that is intermolecular space and intermolecular force. What is intermolecular space? If I am talking about two molecules in a matter, so the distance between them, that is called intermolecular space, and the attraction force between them, that is known as intermolecular force. So intermolecular space and force also we have learned. Now we are coming to the next part, cohesive and adhesive force. That also we have learned in the previous class. Cohesive force, it is the attraction force between two same kind of molecules. Assume, we know, if I am talking about the attraction between two water molecules, these are cohesive force. But if I am talking about that, if I put our hand in water, our hand is wet, because there is an attraction between our hand and that water, so that is adhesive force. Okay, adhesive force is attraction force between two different kind of molecules, and cohesive is attraction between two same kind of molecules. That things we have learned. Now we have next we have learned that states of matter. So depending on the properties of the matter, depending on the attraction force between the molecules, we can divide the matter into three parts. That is solid, liquid and gas. If I'm talking about the example solid, we can say that wood, stone, brick, whatever the things I have taken in my hand, the pen, everything is solid. In solid, the intermolecular attraction force is more. Coming to liquid, water, okay, kerosene, alcohol, all that things are liquid because their attraction force is less than solid. Next, gas. Okay, oxygen, hydrogen, carbon dioxide, these are gas because their attraction force is much lesser. Okay, so what we have to learn today, what is today's work, that the things we have discussed in the previous video. So those who have not seen the previous video, please go and see this, otherwise you can't able to understand. Today we will start the molecular model of solid, liquid and gas. Here we just try to understand that how the molecules are arranged inside a solid, inside a liquid and inside a gas. Let's see. Okay, so our next target is molecular model. Molecular model. Okay, let's see. Molecular model. Okay, so here we have to see the molecular model of solid. So we have to write here. So here we have to draw the molecular model of solid. Here we have to draw the molecular model of liquid, and here we have to draw the molecular model of gas. So make a partition, liquid and gas. If I'm talking about, this is a portion of a solid. How the molecules are arranged inside it, let's see. Okay. If I'm talking about the arrangement of the molecules inside the solid, they are very much close. It is told it is closely packed. Okay, so as we have taken a part of the solid, it seems to be that in last portion we cannot able to cover the whole molecule. We have taken the little portion here. Okay. Okay. So that is the closeness we can able to see the molecules inside the solid. You see, these all the circles I have made, these are the molecules, and inside the solid they are very much closely packed. Okay, they cannot able to move. You see, they cannot able to move here and there. Okay, so what will happen? We have already learned in the characteristics that the particles are moving randomly, but for case of solid it is not possible. The particles cannot able to move. So what can particles do here? The particles can able to vibrate at their own place. So we can able to see the vibration of phone. So the particles, if I'm talking about the particles, it just starts vibrating. Okay, it can able to vibrate, it can able to move here and there. And by see the diagram, we can see it is closely packed, closely packed. Okay, very much close. And by see it, as it is closely packed, we can say that the intermolecular attraction here maximum. Otherwise, it cannot be closely packed. So we can say that intermolecular attraction maximum. Intermolecular attraction is maximum. Okay. Now, due to this arrangement, the solid become very much rigid. The solid we have seen around us, they are very rigid. If I am talking about wood, if I am talking about plastic, stone, okay, and iron, any metal we can take, they are rigid and they are having a definite shape. Okay, so from this molecular model only we can able to define solid. What we can say? We can say that solid is a substance of rigid and definite shape, and where the molecules are very much closely packed. That type of substances are solid, or that type of matter is known as solid. Okay, I think you have understood the molecular model of solid. Now we have to come the molecular model of liquid. What is the molecular model of liquid? The molecule for liquid we know it is generally stays in a container, and that is the level of the liquid. What will be the arrangement of the molecule inside the liquid? Inside the liquid, the molecules are staying like this. They are not much compact like solid. They are just arranged this way. Okay, but we have to do one thing. The shape should be same. Maybe I have drawn by my hand, so maybe the shape is a little bit of different, but it should be same. So these are the arrangement of molecules inside the liquid. Whether they can able to move? Yes, they can able to move in any direction. They can able to move in any direction, but they cannot able to cross the boundary. They cannot able to cross it. We can write they cannot able to cross the boundary. Okay, the boundary means the surface, the top surface we have seen. The top surface is there. The molecules cannot able to cross the surface. They can move inside the liquid, but they cannot able to cross it. Okay, this is the molecular model of liquid. If I'm talking about the characteristics here, we have discussed characteristics earlier also, but depending on the molecular model, what characteristics we can say here? That they are having a kinetic energy. Energy means I'm talking about the molecules. They are having the kinetic energy, but they cannot cross the boundary of liquid. They cannot able to cross the boundary of liquid. And easily it is not closely packed. So we can say not closely packed like solid. Okay. And intermolecular attraction is lesser than solid. Okay. So we can mention here the intermolecular force is lesser than solid. Okay. Okay, let's check it once again, because see, I don't know whether my camera is covering the whole board or not. That's why I've gone. I think it is covered. So intermolecular force is lesser than the solid. So here, by see the characteristics of liquid, we can say it is non-rigid. It is not a rigid thing, right? You see, it is not a rigid thing. And number two, it is not have definite shape. Okay, so it is non-rigid and not have definite shape, but as it is been fixed inside the substance, so it have a definite volume. It has a definite volume. So if I want to define liquid from the diagram, what we can say, that the liquid is a non-rigid, definite volume but not a definite shaped substance having kinetic energy inside the molecules, and they cannot able to cross the boundary. This should be the definition of liquid by the molecular model. Okay, now coming to the last. Okay, so last one, you can say it is the last boy of the class also. Okay, because I am telling one thing, in my class no last boy, no first boy, everybody is same. But for gas, its molecules are very bindas, we can say. They can move anywhere, any direction. No boundary is there. No boundary is there for gas. They can move any direction. Any direction they can able to move. This is the molecular model of gas. There is not movement of particular direction, nothing. Any direction they can able to move. So if I have seen by the property of it, so here we can say kinetic energy. Okay, so kinetic energy is maximum. By the way, in the previous class, many students is having a question, what is a kinetic energy? I have told you again, kinetic energy means as the body moves, okay, it is in motion, and due to the motion of the body, what energy is possessed? Due to the motion of a body, what energy is possessed in the molecules, that is called kinetic energy. Here we have written Ke. Ke means kinetic energy. Ke means kinetic energy. Okay, kinetic energy is maximum. Number two, no boundary. Okay, no boundary is there, and the least intermolecular force of attraction. The least intermolecular force of attraction, that is the minimum. Okay, this is known as gas. Okay, so for gas, if I define the gas, we can say gas is a substance whose kinetic energy is maximum, intermolecular force is the lowest, and it is not having a definite shape, not having a definite volume. That type of substance is gas. Example, if I want to give example, many more example is H2, N2, hydrogen, nitrogen, oxygen, carbon dioxide, these all are gas. Okay, for liquid we know water, kerosene, alcohol, these things are liquid. For solid, many substances are there around us. Okay, so this is the molecular model of solid, liquid and gas. See it, try to understand. I have already sent a note. Read the note. I think you can able to understand. Okay, now we have to see Okay, in this part we will see the difference between solid, liquid and gas depending on some properties. Depending on some properties. Let's see. We can say it is the distinguish between solid, liquid and gas depending on different properties. So I am erasing this thing. So this part is very important in the sense the question may come that draw the molecular model of solid, liquid and gas and write the property of solid or write the property of liquid or write the property of gas. This type of question may come. So my suggestion is go through the book. Though you have not got the book, I think you will get soon. When you will get the book, then you read the book. Until you have not getting the book, go through the note I have given. Okay, it is very important you go through it, and the questions I have given you just read it. So we can say it is a difference between solid, liquid and gas based on some properties. Okay, so here we have to make a heading, the properties. It is properties. Okay, so these are the properties we have to write in this side. Next here, solid. For solid we have to get this much of space. Liquid. Okay, and last one is gas. Okay, so we complete it. So you may ask that how many times you have to write down the difference. See, in your book, if you go through the book later, whenever you will get it, then you will feel that the difference between solid, liquid and gas, that is the main part of this chapter on different properties, on different things. So we have to do it various time. Okay, so let's see. The first property, it is given that mass. The first property, it is mass. So if I am talking about the mass, all the three substances, solid, liquid and gas, we have already told these are parts of matter. And whenever we have defined matter, we have already told that matter means it should have a definite mass and it will occupy a space. So it should have a definite mass. It is also having a definite mass and it is also having a definite mass. So you cannot say it is the difference in the sense, it is basically the characterization what we have done in a form of column. Now the next property if we go through, that is shape. If I am talking about shape, solid, it is having a definite shape. Any solid substance if you take, okay, assume this one, all the paints we have seen around ourselves, the board, everything is having a definite shape. Okay, but if I'm talking about liquid, is liquid have a definite shape? We know that it is not having a definite shape. It will take the shape of the container where it is kept. So no shape, we have written no here. For gas, there's no question about that. No shape is there for gas also. Okay, now we have to go for the next thing, that is volume. Okay, for volume, if we see that solid, it should have a definite volume. Every solid substance is having a definite volume. Okay, if I'm talking about liquid, it is also having a definite volume. Means the amount of liquid, if you put it any container, the volume should be constant. If you change the container, the volume of liquid is not increased. So volume is definite for a liquid also. But for gas it is not having a definite volume. Whatever the container may be, it will take that much volume. Okay, so gas is not having a definite volume. Okay, anywhere you keep it, it will be moving everywhere. Number four is a very interesting thing, that is compressibility. Compressibility means it is a property by which you can able to change the volume by applying pressure. Later you can able to know it, but now you just try to understand what is compressibility. Compressibility is a property of a substance by which you can able to change the volume, you can compress the volume by applying pressure. Okay, and whatever the volume you have achieved, that should be permanent. You cannot change it later. If I'm talking about solid, we know that we cannot able to change the volume, so compressibility for a solid, it is zero, no compressibility. Okay, we cannot able to compress a solid. If I'm talking about liquid, very less, so we can say least, or we can mention here negligible, though generally we cannot able to compress liquid, but then also it is a chance that we can able to compress it, but very less, negligible. But gas, yes, we can compress it, so we can write that yes, the gas having a definite compressibility, we can able to compress the gas. Number 5. So number 5 property will go for the fluidity. What is fluidity? Fluidity means the ability to flow. The ability to flow a substance. Can solid able to flow? Definitely not. Solid cannot able to flow. If I talking about liquid, yes, it can able to flow. If I talking about gas, yes, it can able to flow. But in between liquid and gas, whose fluidity is more? Definitely the gase's fluidity is more than the liquid. The gas can move faster than liquid, so the fluidity is more in gas rather than liquid. Now we have to come next part, number 6, rigidity. Just now we have discussed now rigid. Which substance is rigid? For solid, we can say its rigidity is maximum. Okay, maximum rigidity. So the solid substances are rigid. If I am going for liquid, the rigidity is not there, no rigidity. If I am going for gas, oh no, it is not possible. For gas, there is no rigidity. Now I have to come the next one. It is very interesting thing, that is called diffusion. In the previous class only, you have asked, some of the students have asked about the diffusion. Sir, what is diffusion? Diffusion is a property by which a substance is moving from higher density to lower density. Higher density to lower density. See, I've given you an example. Assume if I have kept one solid substance is one corner of the room. If you come after some time, you see it will be there. The solid cannot able to move in another part of the room. It cannot able to diffuse. Okay, so for solid we can say the diffusion is less or no diffusion is there. For liquid, if you put liquid in some place, it will just spread everywhere, but then also the diffusion is less. But if I'm talking about gas, assume many of you are having in house the room freshener. In any corner, if you spray your room freshener, you will feel that after some time that smell will distribute whole the room. That is diffusion. You spray just one corner and it is distributed to whole room. That is from higher density to lower density. So for gas, the diffusion is maximum. For gas, the diffusion is maximum. Now we have to come to the next part, that is packing of molecule. Packing of molecule. If I'm talking about solid, it is closely packed. That just now we have seen, closely packed. If I'm talking about liquid, less closely packed. Okay. Less means it is less than solid but more than gas. But if I am talking about gas, no closeness in packing. No closeness in packing. Okay. So three things we have seen: closely packed, less closely packed, and no closeness in packing. No closeness in packing. Now we can discuss one more thing, that is number of free surfaces. Okay, now just read it. Okay, or if you cannot able to understand, just pause it, pause the video and see it. I am going to the next part. Okay, so I'm erasing this part. Next one, it is very interesting, that is number of free surfaces. Number of, so up to here we have written 8, so here it will come 9. Number of free surfaces. So if I'm talking about solid, there are many free surfaces are there. Any solid, if I have taken any solid, if I have taken this diary, you see, okay, so 1 2 3 4 5 6 surfaces are there. Just like if I have taken any solids, they are having different surfaces, so many free surfaces. For liquid, there is only one free surface. If I'm talking about the liquid, it is kept in a container, and you see it is having only the free surface at the top. Okay, rest there is no free surfaces. Every part is closed by the container. So here only one free surface, and gas, no free surfaces. Because you see, the gas is not a rigid substance. If it is not rigid, then how there will be the surfaces? As it is not rigid, then how it will be surfaces? Now I am talking the next part, that is very much common now, that is intermolecular force. So you know, for solid it is maximum, for liquid it is less than solid, and for gas it is minimum. Okay, or you can say negligible. It is negligible for case of gas. Okay, now the next part, that is intermolecular space. Intermolecular space. So there are intermolecular space, if I am talking about, it is minimum, it is more than solid, and here it is maximum. Okay, number 12. These things we have not discussed because we have discussed it earlier very much. Expansion on heating. See, this part you have to understand very clearly, because based on this we have to go to the next part, that is change in state. Expansion on heating means whenever we have given heat energy to a substance, it just expand. Now the question has come, why it will expand? Why it will expand? Due to the heat energy. I have to mention one thing. As you have given, so here I have to discuss one more thing, then we have to write down later. More heat energy, I have mentioned here. I have to mention here. More heat energy equals to more kinetic energy. Energy of particle. So if you supply heat energy to a substance, the particles are moving more. If they are moving more, their kinetic energy will more. So initially how much space they have taken, if they are moving more, they will take more space and they will expand. Now the question has come, you might be thinking that, sir, for the case of solid, they cannot able to move. Then what will happen? So we can write here, for solid, more heat is equals to more vibration. How? Assume this is a substance, this is a solid molecule, it is vibrate like this way. More heat energy you given, that vibration will be increased like this. So as it is vibrating this way, so definitely the initial space it will occupy. If it's vibrate more, then the space will need more. If it needs more space, it will expand. So for that reason, the expansion occurs. For that reason only, more heat energy, more kinetic energy or more vibrational energy, and for that more expansion. So definitely if you see for solid, that expansion is less because its attraction force is more. Is intermolecular attraction force is more, so its expansion will be less. If you talking about liquid, it is more than solid. And if I am talking about gas, it is maximum. For gas, you know, there is no intermolecular force or negligible intermolecular force, and that's why it can expand more. Clear? Coming to the next part, part 13, motion of molecules. Motion of molecules. So that is also explained in this part. So motion, if I am talking about, it is maximum for case of gas. For liquid, it is more than solid, similar exactly. And for solid, it is minimum. Or we can say for solid, in general, no motion is there. In general, there is no motion. But if you have given heat energy, it starts vibrating. That you can take one type of motion. But in generally, the molecules are not having any motion. They are closely packed. Okay. Last two properties we have to discuss, and then this part will be over. Last two properties. Let's see what are the two properties. Okay. If you are not able to write it down or not able to understand, then pause the video here, see it again and again, then you will understand. Okay. Last two property. Number, I think it is 14. Viscosity. Viscosity. What is viscosity? It's a very hard topic. Okay. No need to learn much about that, but viscosity means the fluidity of a liquid, how fast it can able to flow through a solid. Assume you are having 1 mug of water, you just fill it in the floor, it will flow. Assume in that mug you have taken 1 mug of any another substance, just like mobile. If you just throw it in the floor, you see the movement of water is much faster than the movement of the mobile, because the mobile is little bit of sticky, they cannot able to move faster, but water can able to move. If I have taken 1 mug of kerosene and throw it, then you see the movement of kerosene is more than the water. So this property, whenever we have discussed all through the liquid. Okay, so for solid, no viscosity is there. For liquid, we can able to see the viscosity, and it is the maximum. And for gas, though it is called negligible, but you have to mention least. But in generally, it is negligible. In gas, we cannot able to see it. Least viscous. Okay. So for solid, there is no viscosity. Liquid, it is maximum. Gas, it is lesser. Mainly viscosity is known as, you know, it is the friction. Friction, you know, when a solid is moving through another solid, there is a force which try to oppose the movement. Viscosity is the friction between the liquid. Viscosity is the friction between the liquid only. So that is the property of liquid. Simple thing. You have to remember viscosity is the property of liquid. Solid and gas is not correlate with that. Number 15 and last one, surface tension. So though there is a name in tension, but I am assuring you there is no tension. What is surface tension? That is also a property which is there in for liquid only. For solid, no surface tension. For gas, there is no surface tension. Only the liquid is having surface tension. So we can say it is yes, the liquid is having a surface tension. Now, little discussing what is surface tension. Surface tension is the property of a liquid by which it will just try to occupy less amount of area. We have learned area in class 5 now. Area, the surface occupied by an object. Liquid, it just try to occupy less area. It is the property. That's why if you put water in floor, or if you put water on lotus leaf you know, if you put water there, the water will be there as a form of complete a spherical ball, just like a ball. It can able to move through it. Okay, but if you throw it in floor, it will be there just like this way. Now there is a question that why it is taking this kind of shape. It can take this type of shape. Why it is not taking? Because this shape, by this shape, it can occupy the least amount of area, and that is the property which is known as surface tension. So surface tension means the property in liquid by which it will occupy less amount of area. And here also for solid and gas, it will not going with the surface tension. Okay, so up to this is the part 2 of matter. Okay, and next part we will do, that is change in state of matter. Okay, thank you.